Well, I know you guys have set up a little project for me to try to work here. Why don't you explain a little bit what we're going to do and what we've got prepared here?
Long story short, this is kind of a rough draft of what's in a standard windmill. And this is a generator.
Made out of like a hard drive, and then you take some screws and you wrap them around with this magnetic coil, and then as the magnets go around, they induce a voltage. And that's basically like,
you know, those big windmills that you see, say, out in the middle of the water or stuff like that?
Okay, we're up in Ubley where we've got all those farms up there with windmills. Okay.
This is kind of how it works, it's a smaller scale.
Okay.
How it works.
Okay, so we took an old hard drive from a computer or something like that, right?
Yeah.
Okay.
We took a few nuts and bolts, and we wrapped some metal wire around it about 300 times.
So what is it? This is to help us make like an electronic magnet?
Yeah, when you run the electricity through a wire like this, it creates a current,
Okay.
and that's what starts up the magnetism.
Okay, so then we spin this, and then what happens?
Well, when we spin this, you'll see, we'll get a reading on here.
Yeah, it makes
It's actually a
voltage.
pretty strong magnet, so it's difficult to spin, but it's similar.
Okay, and so this is really the same concept as how they generate electricity.
Yeah.
Or how with the windmills and things that as they turn, then that shows how that generates electricity that we'll be using.
Yeah, how we're generating this with our hand right now, the wind would be doing the same thing with a windmill.
Okay, I'm going to go ahead and spin this, and I'll try to keep it spinning. Tell us what we're seeing on the meters, if you would, okay? Here we go. And then I'm just going to keep it spinning. Of course, I can't keep a very steady spin here, but so what are we seeing on the oscilloscope over here?
When you're spinning, you're seeing a wave, and that's the voltage peaks that you're getting from when you spin that.
Okay, obviously I'm not generating a whole lot of voltage. I probably couldn't even light a light bulb or something right now, right?
No.
Oh, yeah.
So, okay. But then, so with using the wind turbines, then as the wind speed increases, and obviously they'll be generating more electricity.
Yeah, the voltage will increase.
Yeah.
Okay, good. What about the other direction? Does it change anything? I can't see the oscilloscope either, but does it change anything?
No,
or is
it doesn't.
No.
It spins either way, and it works.
Same concept, just different direction, just like the wind.
Sure.
Yeah.
So what we're actually creating here is what? Alternating current?
Yeah.
Yes.
Okay, so that's a little different we have in our batteries and things.
Yes.
Yeah, because when the magnet, when you're rotating it and the magnet's being drawn apart from it, you're forcing the electrons to move apart, and when it comes closer to the other magnet, it's drawing it to it, so you're moving the electrons around.
All right, so then obviously the faster the speed, the more voltage. What about amperage? Does that create amperage in there too, or is that where the transformers come in to change all of that stuff?
I think that's where the transformers come in.
Yeah, I mean, electricity, I mean, it's something we definitely take for granted around here. Just flip the switch, and especially here in St. Clair County with all the power plants we have, but this is the same concept, isn't it?
Yeah, it's just a different way of getting the same fuel.
Okay. What have you kids learned by doing projects like this in the class? I mean, how does doing something like this help you to learn better?
Well, it really opens your eyes to the world around you, I guess you could say. I mean, before I really didn't care what was in my TV as long as it turned on, and now I look at it and I'm like, what is powering this? How am I getting that? You know, what's really inside this thing?
Okay.
So it really opens your eyes to that.
Great.
Plus, when you can physically see something, it helps you better understand it too. Like, I wouldn't have understood how, like, if somebody said, like, when a magnet spun around, it induced a voltage, I wouldn't have got it. But now once you see it, and once you see how it does it, it makes a lot more sense. It's a lot clearer.
Great. Have you been able to apply this at home at all yet?
Oh, absolutely. So I kind of brag about this a lot, but at home I'm currently making these KC lights out of LEDs.
Okay.
And I'm using different colored LEDs, using different designs. I'm making my brother a MSU one. So it's cool stuff like that. I'm able to build stuff at home.
Great. Danielle, I know you're just getting into the program. What do you hope to do learning this type of stuff, and how you're looking to apply it?
I'm just hoping I can make a lot of different things. That way it shows, you know, the diversity of this program. So, you know, I'd like to spread the word about it, to be honest, because I think it's a great opportunity for a lot of people to do, and I think everybody should do it.
Okay, well, great. Well, great learning a little bit about it. It's been great meeting you folks, and I just wish you best and hope you get that internship this summer. And
Thanks, me too.
And Danielle, hope to get to see you around here next summer as well, or next school year too. So thanks for joining us here on Technically Speaking. It's time for us to take a break, so we'll be back in just a moment, so don't go away. Joining me now on Technically Speaking is Jim Muldoon. Jim is a 23-year veteran and captain of the United States Air Force and now serving as a civilian for the United States Army. More importantly though, Jim is a trustee on the Yale Public Schools Board of Education and a 1984 graduate here at St. Clair Tech. And Jim, welcome to the program, and give us a little bit of your background and how you got started with your educational process here at Tech.
Great. You know, it's an honor to come back and to be here and for you guys to take this time and give it to me. But, you know, being a small farm boy out of the country, out in Avoca, spending my time out there and then going to Yale. And back in the 80s, you know, I must admit that the economic future looks similar to what it is today, and as well as the global tensions. And although we weren't at war at that time, it was inevitable. But, you know, I didn't want to go to school anymore. I thought I had my fill of it, and Tech provided me a chance to work with my hands. But what I decided is that, yeah, I can pretty much work with my hands, but I really need to get into electronics. That was the future, and I'm glad I made the right choice, but Tech was definitely the foundation to get me there. And then looking a little farther into the future, I had signed up for the Air Force, as you had mentioned. So before I even graduated, I had a good foundation with the Air Force as my next career. And technically it was going to be electronics. Tech gave me the foundation required to get a high score on my ASVAB test, so I had a guaranteed electronics job.
Well, right now you have a pretty unique position that you're doing with the Army as director for TARDAC.
That's right.
And Mike referred to it a little bit in the previous segment, so tell us a little bit about that
job. Well, and doing electronics in the Air Force initially for about 14 years, working on radar receivers and jammers and doing some teaching, going over to England, even got to do some wrestling in there, which I came back and had a chance to help out with Mike as well. But I never thought that being a technician, thought that was going to be my career, but the Air Force sent me to an active duty scholarship for electrical engineering. So for 2.5 years, the Air Force paid for me to go to school at Texas Tech. Do electrical engineering. Opportunity there was hybrid electric vehicles as my senior project. Being the team leader when I graduated, it helped to be national for the Honor Society as well as outstanding senior out of Tech, and I appreciate those as well. But the Air Force thought it'd be a good idea for me to expand that and go into manage their electric and hybrid electric fleet and be their electrical engineer for those programs. It's truly an honor to work on the premier weapon systems of the U.S. Army in the world.
If you had a chance to talk to a student who was considering going to Tech, what would you tell them?
One, you know, be clear what you want in life, and it's really hard to do that as a student. But if you're set and got an idea that this is what you want to do, Tech is definitely an opportunity to lay that foundation out. It's truly a benefit for me overall. You know, you can build upon past successes, and Tech was definitely a success for me.
This is going to wrap up this program. We want to thank you for joining us for this premiere edition of Technically Speaking, celebrating 35 years of St. Clair County Tech. We hope you've enjoyed this glimpse into the Energy Technology and Services program, and I'd like to thank the instructor Dave Lawrence, his students, and Jim Muldoon for giving us some more information on this brand new program here at Tech. And we encourage you to learn more by visiting our website at sctech.org. We invite you to join us on the next edition of Technically Speaking, when we will learn about Tech's engineering, graphics, and animation program. Thanks for joining us, and we hope to see you next time we are Technically Speaking.